Let me go to the live interface of the Allegro. And I would like to describe in the first step the setup. So I'm now on an Allegro 1000, but this is not basically that's not very important because the web interface, the complete firmware is the same for the very low end 200 up to the 5500. So once you know one engine, you know all of them. And we decided to make it very clean and easy to use. First of all, the management is out of band. So we never introduce any packets or so into the client network. The navigation the design is quite simple. You have here on the left side the navigation similar to the OSI layer. So if you're interested in layer 2 statistics, we can go into here in detail, but we can also go into layer 7. I will walk through that in a minute. On the other hand, we have a timing navigation here. And just to show you what it can do, I can just zoom out easily to 1 day. And if you're now interested in specific time range, you can just zoom in with your mouse. And then our database selects now this time range. And all statistics of the Allegro are now tuned to that time range. So I can see immediately that we had 500 megabit traffic today at 2 a.m. and our VM host office transferred data to our disk station. So we did a backup in the night. And these are things you can see immediately by just zooming in and out the time as a time interval. The use case here is very simple. Whenever you hear something like, oh, I had a problem that morning, or my VoIP did not work that morning, or I couldn't access that website this morning, it's very easy to zoom within seconds to that interval. And then look what happened there. Very often, problem A has nothing to do with it. So if, for example, the DNS server didn't work for 10 minutes, then the people will complain that the internet didn't work, but they don't complain that the DNS didn't work. So how to figure out these things? Okay. So that's a generic overview. The Allegro, just going into a very few modules, can do analytics from very below, what we call burst analytics, where we simply sample the utilization in milliseconds. And whenever there is a utilization, well, the problem here is that if you have average utilization of, let's say, 1 minute graph, you never know, was there a peak in the network? So we decided to implement a burst analytics where we measure in per millisecond what was the load for that. And if we see here a peak, we can easily zoom into that peak and see it was again 2 a.m. that our 500 megabit transfer created at some point, for example, here a load of 7%, which means 70 milliseconds of that 1 second, the link was fully utilized. And for example, at that time, maybe VoIP could be degraded by that backup. And that's very easy to see. Okay, I had, for example, VoIP issues. Do I see some burst in the network? If yes, okay, we at that time, who was it? Let's go back to the dashboard and we see, at that time, it was these IPs sent the traffic. So that's very good where you can start with burst analytics. Of course, you can see a lot of other statistics. So for example, per VLAN, where we show you single tagged or double tagged VLANs. Right now, I have only untagged here, or very few packets with a VLAN tag, and where you can see into which VLAN is there. This goes up to, for example, MAC addresses, where you just see all MAC addresses. And just demonstrating here a small feature. If, for example, if you look at the broadcast MAC address, you might be interested in seeing, okay, for example, who did most broadcast packets in the network? Broadcast is normal. The problem is if they are too much, it's traffic for everyone. And someone played around with let's disable the counters for a minute. So we see here that this Allegro sent most broadcast packets. If we are now, for example, interested in them, we can just mark a time frame. And now from that time frame, we can extract back in time the PCAP. Wait, let me check. I just got a new developer version. Let's do that maybe better on IP addresses. We're about to release a new firmware this week. And here we go. But that was wrong. Let's go back and do it again. So we're at broadcast, and if we go here, the peers, and now extract here a few packets, we can, for example, even do us a WebShark preview, where we re-extract now these packets back in time. I might select 4 hours, and now we get all broadcast packets in an easy web view for the Allegro, and can, well, look now even on packet layer what happened there. The main reason why we implemented the packet layer is that it's a proof. So whenever you need the raw data to see, was it really the issue, you can go back to the packets. That makes troubleshooting a lot easier, especially for protocols like VoIP, like HTTP, where problems could be in the header. And this allows you to look very easily into it. When we come to layer 3, I can show you here a very simple example where you can see what the real-time aspect means for the Allegro. So what we can do here, first of all, we see many IP addresses. So we have here 2,300 pages, each page by 5 IP addresses. Well, it's almost 15,000 IP addresses. What you can do here, you can search in real time for specific names. So we can search, for example, for Heinen. What we see here is, okay, there's an IP address which has a correlation to Heinen. How do we do that? We decode the traffic in real time. Once it's decoded, we correlate the DNS request to the response and correlate that information in our in-memory database to the IP address. And now, once this is done, we again allow the lookup in the database in real time for random names, so for any name to match. Here, we can now look into who did this access. And well, I switched my notebook, which was named Nina before. So my DHCP name is Klaus. So that was me this morning. And I can then also again go back to the time frame where I had the traffic. And let's zoom in a little bit here. And then, of course, I can do the same again. And look with the WebShark view, what happened at the time, what did I access, let me stop that the WebShark opens and see, okay, that was a request, for example, which was done here by SSL. But of course, we can go now a lot more in detail. For example, we can see even all connections that happened at that time, including a lot of TCP parameters. We can, of course, see TCP statistics for that IP. So how many connections have been done? What was the retransmission rate at that point in the middle of the network? So there's a lot of also detailed statistics, but again, also a very simple overview, what happened at which time in the network. And here the idea is really to minimize the time for troubleshooting, not to present you very, very complicated, very long PDF documents that are generated once a day. It's the opposite. It should be very fast to access.